Class Multi-Axis Manipulator Control System Operation Teaching. Function Security Point Settings. Click on Function Security Point Settings. We can set safety points for axis X1, X2, Z, Y1, and Y2. Setting of safety points for X1 axis and X2 axis. Mechanical length. That is, set the maximum distance that the X-axis can move. The same applies to other axes. Min pass inside mold and max pass inside mold. That is, after the Y1 axis descends into the mold, the minimum and maximum positions that the X-axis can move to. Assuming the maximum movement of the X2 axis is 500, the minimum position for in-mold descent is 120. The mechanical length is 400. Set in. The movable range of the X2 axis of the robotic arm is 0-500. After the Y1 axis descends into the mold, the movable position of the X2 axis is between 120 and 400. It should be noted that the movement position of the X1 axis also depends on the parameters and limits. If you set the mechanical length of the X-axis, you also need to adjust the settings within the limits. Generally, the maximum position of the X1 axis in the mold's internal and external rise is consistent with the mechanical length of the X1 axis. Inside up X-min and inside up X-max. It can be understood as the safety zone when the robotic arm is not lowered and is at the original position, as well as the minimum and maximum positions of the X1 axis when rising outside the mold. It refers to the safe range of motion for the robotic arm when it moves outside the mold to pick up and place objects. Here, we set it based on actual conditions. Let's look at the settings of Y1 axis and Y2 axis. Mechanical length refers to the maximum height of descent along the Y-axis. Max standby pass refers to the maximum standby position point of the Y2 axis. Leave origin pass, that is, the position where the Y2 axis descends and leaves the origin switch. Assuming the mechanical length is 900, max standby pass is 150. Leave origin pass is 895. The descending range of the Y2 axis arm of the robotic arm is 0-900. The standby position is between 0 and 150. The position that can be lowered from the original point is 0-895. There is a 5 mm reserved gap from the maximum standby position. Next, let's look at the setting of the Z-axis. The mechanical length of the Z-axis refers to the maximum distance it can travel from the origin to place the product. Internal security zone refers to the location where the in-mold material retrieval safety zone is set. Setting 300 here can be understood as the area of the in-type safety zone is 0-300. It should be noted that the setting of the internal security zone needs to consider the Z-origin signal. If the sensing range of the Z-origin signal is 0-200, the internal security zone should be set to 200 to be effective. External security zone refers to the designated location for placing the product safety zone outside the specified type. The setting of 900 here can be interpreted as the external security zone, meaning the safety zone for the robotic arm to place products is within the range of 900 to 000. It should be noted that the setting of the external security zone needs to consider the security zone outside signal. If the signal sensing range of the security zone outside is 800, setting the external security zone to 800 is effective. We see that all joint safety point settings are tested for both forward and reverse rotation of the motor. When a certain axis malfunctions, we can determine whether the motor rotates correctly through this test. The test value is generally 10,000. The feedback value is also 10,000. If the test and the feedback are inconsistent, then the tested axis motor is abnormal.